Okay, so good morning, all, and welcome back to the session. Friends, we are going through with the fine tuning phase. Fine tuning is nothing but changing the weights of large language model in order to improve its performance. And once we are talking about fine tuning, what we have seen it is of two types: parameter efficient fine tuning, which is the most preferred class of fine tuning, where we are tuning the weights, smaller weights of large language model. But irrespective of this, what we are having the full fine tuning as well, where we are going to change all the weights, tune all the weights of large language model in order to improve the performance. Now, one important thing is there that you need to understand. Uh, from that important aspect or important thing perspective, uh, say if we are having a generalized model, why we need to have fine tuning? So, say initial model or LLM basically. Initial LLM is generalized one. It is not having the domain specific expertise. And because of that only, it is not able to provide correct output. This is the case, huh? We know it very well. Are you able to get what I have mentioned with respect to this particular line? Guys, are you able to get?
Yes,
Yes,
yes.
sir.
Okay, so the main thing is that like it is not having domain specific expertise. You can take it into this particular way. Say you have a pre-trained model, or you can say base model or foundation model, and that is generalized one. It means like it is pre-trained onto the data which is available onto the internet or Wikipedia or any other sources which is, you can say, publicly available. But it is not having organization specific data while pre-training, so it will not be able to provide the outcome with respect to that particular organization. So what we need to do, we need to have the fine tuning. And in another word, it is something, say, what we are adding on pre-trained model, LLM, we are embedding what? Domain expertise. Okay. Are you able to get with respect to this particular line? On pre-trained model, we are adding certain domain expertise, and it will be then fine-tuned model. Is it fine? Say yes or no.
Yes.
And say this is the generic model, and say domain specific expertise, and then we will be having the fine-tuned model. Is it perfectly fine? Okay. Is it fine, guys? Are you able to get?
That's correct. We got it.
Okay.
Yes, it's fine.
So let me take an example. Say I'm having a LLM with 1 million parameter. I am having one LLM with 1 million parameter. parameters, and it can be represented as say 1000 cross 1 and cross 1000 cross 1, and it will give me what, 1 million parameter. Is it fine? Is it fine? Are you able to get in matrix form?
Yes.
Okay. So over here, like say we are having say two matrix, matrix one say, or matrix one, that is having say 1000 weights, and matrix two, that is also having 1000 weights. So total weights say 2000 weights. Okay, so what I'm planning to say over here, uh, once we are going to perform the fine tuning, we need to have two matrix in order to perform this particular task. Okay, and those particular matrix are called adapters. Okay, so uh, in order to perform fine tuning, we need to have two additional matrix apart from pre-training matrix, and these two new matrix are called adapters. So over here, say if we are having 1 million parameter and we are mentioning it into this particular way. So So what this particular matrix is denoting over here, that the rank is 1 over here. If like 1000 is multiplied by 1, so it is say rank 1. If like it is 2, so what it will be? Then I will be having say 4000 additional parameters. If it is say 3, then I will be having 6000 additional parameter. If it is say 8, then I will be having 16,000 additional parameters, or you can say the weights with respect to this. Okay, we will be having the discussion in detail. No need to worry about these particular aspects, but try to focus on to this particular line. Once we are going to perform the fine tuning, then we need to have two additional metrics apart from the pre-training one, and these metrics uh, are called, you can say, adapters. Now these particular adapters are utilized, or you can say these are called LoRa adapters. I haven't mentioned one thing. So with respect to the fine tuning, guys, we will be going through with parameter efficient fine tuning only. Full fine tuning, we are not having that much, you can say, computation capabilities in our machine. We will not be able to perform full fine tuning. So for learning perspective, we will be moving with the parameter efficient fine tuning. And for that, say I have mentioned 2k chains, say 2k parameter chains. So that is taken with respect to this particular matrix only. So we will be going to tune some of the weights from our large language model, and then we will be going to validate the performance after changing those particular parameters. So I have picked the parameter efficient fine tuning, and what I mentioned it is of two types, LoRa and quantized LoRa. Okay, and in the LoRa or parameter efficient fine tuning, the adapters are called, you can say, LoRa adapters. Two metrics are called adapters, and these are called LoRa adapters. Because we are moving with parameter efficient fine tuning, adapters are LoRa adapters. And what I have mentioned, say, what is the difference between LoRa and QLoRa? That is quantized LoRa. So the main difference over here is the size. Okay, the difference between both of these two is the size rated stuff. And what is being happening once I'm talking about the size, say what we are having, say, so size basically, say if the LoRa is going to represent a particular weight into, say, 16 or 32-bit number, it is used to represent weights into 16 or 32-bit numbers. But once we are going to utilize the quantized LoRa, so it is going to represent the weight into 4 bits and or 8-bit numbers. 8-bit numbers. Now, what will happen onto the size if I'm using, say, 4-bit number or 8-bit numbers? How it is going to reduce the size? Mm-hmm. Did you get how it is going to reduce the size of the model or large language model? Once we are downloading a particular model, it is representing, say, downloading uh, downloading this much of data, say 8 GB and all. Are you able to recall, all of you? Guys, say yes or no. I don't think like what is happening over here. Uh-huh. Say yes or no. Did you get what I'm mentioning over here? So just have a look over here. Adapters, fine-tune, quantization. And let me try to provide the size related information.
Okay.
Guys, are you able to get what I'm mentioning?
खाने में क्या बनाऊं?
Are you able to get how this size is going to be minimized by using I need to mute Manish. Okay. How the size is minimized once I'm using 4-bit or 8-bit numbers instead of 16 or 20, 32 numbers. Because can you try how the size is minimized if I'm using 4-bit number instead of 16-bit number? Guys, are you able to hear me?
Yes, yes, you are audible, Ashok.
Then why
Are we
are you?
reducing matrix size over here
No,
when
no,
we
no, no, no. This is not the matrix size, guys. This is not the matrix size. So you can take it into this particular way. Let me try to mention. Say I'm having a particular weight. Say minus 0.2323. Yeah. Now there are multiple ways to represent this particular weight. I can represent it with 16 bit number, and let me try to ask, say, a representation of this. Uh, Guys, please go on mute if you are not speaking. Can you share the 4, 8, 16, and 32-bit representation? Let's see. Like, will we be able to get this information from ChatGPT? Okay. So just have a look over here. This is the representation of our number. This is 4-bit, this is 8-bit, 16-bit, and 32-bit. And what did you get? If I'm going to store this particular number, if I'm having this particular number with respect to this particular weight, so it is going to occupy more space. Is it?
Yes, yes.
Yes, sir. Space, RAM, and everything.
Okay. And once we are going to download this particular model into memory, definitely the memory will be, you can say, occupied more, or it will be there are the chances that it will be washed out.
More resources will be used.
Okay, so what is being happening over here? LoRa, which is the low rate adaptation, the fine-tuned model is having it's going to represent values with 16 or 32-bit numbers, but the quantized LoRa is improved version of LoRa, where we are going to represent it with 4 bits or 8 bits. And what it will do, it will reduce the size, it will reduce the memory footprint of the large language model. And how? Because it is going to occupy less space, it is occupied to it is occupying less uh, storage or less memory, while storing a particular weight. Without weight we can't proceed, so we just need to have the information like how to store these particular weights and all. So this is how the representation is being done for a particular number, okay, or a weight. And then we will be able to see that memory footprint is reduced over here, and this is the enhanced version of say LoRa. Now it might be possible, say, if we are having the good more footprint, but it might be possible it is going to, you can say store more information. Okay, it is going to store more information in terms of what, say it might be possible, say quantized LoRa is going to store say up to 16 or up to say 4 decimal or 8 decimal point numbers, but the LoRa can store up to say 16 or 18 or say 20 or 32 decimal point numbers information as well. So in that particular way, performance might be here and there, but it will not have a major impact. So quantized LoRa, that is the enhanced version of LoRa, and it is going to reduce the memory footprint. And how it is going to reduce the memory footprint? This is the method. Okay. Now, if the memory footprint is reduced, what will happen? We have seen.
So,
Mhm.
same way in the LoRa, we can convert into the binary, correct? And we can store into the memory.
Yeah, it is happening. Like
Uh,
LLM is not going to understand these particular things. Oh, sorry, computers.
So, you mean to say for the after the decimal, for the
Mhm.
LoRa can store 16 or 32-bit, but
LoRa, it is not LoRa. It is for the computers to process it, CPU to process it.
yeah, agree. But the thing is here, like you said, like after the decimal,
Mhm.
for in the first case, we can consider LoRa. It can store
Mhm.
the 16 or 32-bit, correct?
Mhm.
And with
Mhm.
the advanced, like the CPU, we can say it can store 4 or 8-bit max number after the decimal, right?
Advance? No, 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 I didn't get it.
Quantized, you mean to say, okay, we can consider first LoRa. You
Mhm.
said like after the decimal value, okay, it
Mhm.
can take the 16 or 32-bit number, correct?
Mhm. Mhm.
And in the quantized LoRa, it can take the 4 or 8-bit number, correct?
Mhm.
So both are stored into the binary format, right?
Mhm.
Okay, but if we, I think, okay, based on the bit, okay, we can say it's an advanced version. But if we
Mhm.
can go practically, I think maybe we can get the exact value from the LoRa side.
So from the number representation, that is perfectly fine. I'm
Okay.
not mentioning that particular stuff. But our motto is to reduce the size.
Mm-hmm.
Correct.
Yeah, that is.
Say,
Mm,
so say if the information over here is up to 4 decimal point, so we can take it say over here 3 decimal point number and then convert it into the respective, you can say, binary numbers. So at
mm-hmm.
that moment, the performance may be here and there.
Okay.
Okay.
Mm-hmm. Mm-hmm.
But will not have a major impact. But yeah, if say weights are there, if we are changing the weights in in a particular way, then definitely the performance will be impacted.
Right. Mhm.
Is it?
Yeah, understood. Thanks.
Okay, perfect, perfect. So quantized LoRa is having less memory footprint, and we have seen the Q LoRa is going to occupy less space. It means less memory footprint, less time to travel information, less time to move data, and less time to process as well. Correct. So what it will do? Improve latency, improve speed and reduce memory footprint. All of these are, you can say, correlated. All of these are interlinked with each other. And like during the interview, it might be asked like, what is the benefit from QLoRa? So these are the benefits. Correct?
Yeah, correct.
Okay. Now, how to implement? How to implement fine tuning? Okay. So what we will do, we will be having multiple steps. Okay. Step one, uh, we will uh, download base model, and we will take distill word base uncased model. Okay, distill bird based uncased. And let me try to check it. We'll be going to take this particular model and distill bird based uncased, and this is the model. And over here, this particular model is having 67 million parameters. If you are able to see, 67 million parameters. Model size 67 million parameters. Then uh, what this particular model will do? Okay, say if I'm checking weather is good, weather ID good. My mistake. Weather is good. Fail to perform inference, no mask. Okay, this is masking model now. Pleasant, mild, good, excellent, beautiful. It is able to say predict. But it is having example 1, example 2. This is perfectly fine. Still bird based on case. The model is fine. This is masking. Classification, I just to check classification. Okay, so note the model is primarily aimed at being fine-tuned on tasks that whole sentence potentially masked to make decisions such as sequence classification, token classifications, or question and answers. So this particular model primarily going to perform these particular tasks, and our motto is to have the classification related stuff. Okay, so what we will do, we will provide some, you can say, sentences, and we'll try to predict like say positive and negative related stuff. We'll try to do the classification with the help of this particular model. Let me mention it over here. Our main aim main aim is to fine tune it for classification related stuff. It might be say 0 positive, 0 negative, negative and 1 positive. Okay, we'll try to do say binary classification with this. Okay, so what we will do in order to have the classification, we will be using the IMDb dataset, and which is having almost a 25k records. Okay, so this is the model. And it is having 67 million parameters. We will try to do binary classification with this on this particular data set. Okay, so data set, inside the data set, let me check, and we can download this particular model. Okay, so probably I have downloaded it. So what you need to do, once you are going to register, okay, and download, but based on case model, download. So download option will be there. Probably over here you will see the download option. Okay, I have already downloaded it. It was introduced this particular paper here. Community. Salesforce generate. Okay, download option is not visible at this moment, but we Distilbert based on case model, you just check it, you just need to log in it, and you need to click on download. It will not be immediately download. It will first verify your request, and it will send that the email for verification. It will take 1 or 2 days in order to have the download of this particular LLM, and once your request is approved, then you will be able to download. Okay, so this is the process basically if you are willing to download a particular LLM from this particular website now. So you need to download in that particular way. So you need to download this particular model, and let me come into the data set. Okay, and IMDb data set we are going to utilize my bird, and this is a IMDb only, my bird dataset IMDb, Stanford IMDb, MMI. This is say IMDb dataset, and 25k rows. If you are able to see 25k rows, so 25k records are there, and just have a look onto this particular dataset. I rented. I am curious yellow from my video store because yellow. What I'm meant to say over here, this particular data set is having say movie records and and all movie reviews are there, and we will be trying to finalize like is it a good review or bad review. like is it a positive review or negative review. So we'll try to download this, but we need to download, and then first we'll check the review with base version, and then we'll fine tune that particular LLM, and then we'll check again with respect to the fine tune model. This will be the process. Okay, so data set and size, plain text, this is, and how to download this, basically. Choose this particular data set, edit, copy to bucket. And just have a look over here, two class, positive and negative. So data set card. And I'm having probably IMDb data set. So simple MN, probably this is the data set. Okay, embedding requirement.txt main. Well, see, if you are not able to download, I will provide this particular data set. I just need to check like how the download will be available. Use this particular dataset, pandas, polars, dataset, and okay, DS. This is the data way, like how you will be able to download it, how we'll be able to have it. Let me try to copy and say paste it over here from dataset, slow dataset, and then say this, what it is saying. No module datasets, load datasets. So let me try to move it pandas way. Okay, this is in Parquet format. IPNB. No. Okay, so just have a look over here. Say rented, I am curious, and almost 25K records are there. So we'll be able to utilize this particular data set in this particular way. Correct? Are you able to get all of you? Hello?
Yes, yes.
Is it fine with everyone? Okay.
Yeah.
So,
Yes, sir.
so we'll be using this distill but based on cased model. And over here, we are having say positive and negative category. Okay. Now, what we need to do, we need to use this particular data set, and our motto is first we will use this particular large language model to predict the values, the reviews, basically is it positive or negative. We'll try to classify into two categories, and then we'll record that particular, you can say, output. Say you can take it in this particular way. Model will be going to predict, say, incorrectly at this moment, because this is a base model. The model, the large language model, will predict incorrectly or provide the not prediction, but it is going to fetch or try to classify incorrectly, because it is probably not having that data. Okay, it is not trained on that particular data. So this particular data, IMDb data set, will be utilized to train our LLM. And then what we will do, we will do the classification again, and we'll be able to get the outcome. So step 2, what it will be? Step 2, then we'll install the required libraries. And there are many libraries that we are going to have. So first one is a transformer. So used to importing pre-trained model. Okay, LLM. Okay, so so there is no need to download. Then in this particular case, if we are using the transformer, the transformer library will download this particular model. So in this particular way, say if we are going to mention, say, transformer pipeline, and if we are mentioning, say, task, say the classification task is there, we are going to, say, mention the LLM model, basically Distilbert based on case, and we will be able to utilize it. So there is no need to download them. Okay, is it fine? Is it fine, guys? If we are using transformer, then there is no need to download it. Okay, now say we are having transformer, then accelerate to train and infer any model. Okay, we'll be using, we'll have discussion on top of this, say, like how to train the model and how to infer the model. That is perfectly fine. Accelerate, then bits and bytes. Bits and byte. And what it will do, it will be utilized, it will be used for quantization perspective. It will be used for quantization. Then we are having, say, PEFT, that is a parameter efficient fine tuning. With the name itself, we are able to get then we will be having, say, data set, to load data set. Okay, so we have used at this moment, what we are doing, not this one. At this moment, we are trying to read with pandas. So previously it was not able to import data set. So we'll be importing data set in order to use this particular data set. Okay, this is another way, like how you will be able to download a particular data set, but we'll be using the data set library in order to load the data set. Then what we can have, evaluate. Evaluate, that will be used to get the standard matrix. Okay, so these are the certain libraries. Apart from this, there are different libraries as well that we'll discuss during our practical. Okay, this will be the second step. Step number 3, what we will do, we will define a model and its parameter. Parameters, and say what it will be, id to label. It will be something like this: 0 for the negative, and 1 for the positive. And label to id. Label to id. So it will be something like this. Okay, these particular things will be used once we will be moving with practical. Okay, or practical implementation of this. Okay, I think this is fine for this particular session, guys. Now, in the next session, what we'll do, we'll start writing the code, and rest of the steps will move during the practical only. Yeah? I will try to keep on appending the next steps. Almost 7 to 8 steps are there in order to have the implementation. So we'll start practically in our next session, and then we will be able to get, it will take 2 to 3 sessions basically more in order to have the understanding of the complete, you can say, parameter efficient fine tuning. And then you will be able to get, like, if based upon a base or pre-trained large language model, how to fine tune it. So this particular LLM will be utilized uh, for parameter efficient fine tuning. We will be having fine tune model as well. We'll give a particular name that will be based upon your wish, and that particular LLM will be going to work more efficiently on a particular data set. We'll see with practical, no need to worry. So I hope you are able to get what I have covered in our today's session. If there is any doubt or confusion, you can ask. Fine so far, guys?